La- Ladies and gentlemen, we just, it's been more than 10 minutes. So let's look at some of our results. So today is as I said, this is my third day doing this. One, two, three. Yeah, third day doing this. So in this case, I have here CO2 after 72 hours. I'm looking at my CO2 um, data today. Now, one thing I do want to talk to you guys about is this. Now, first off, how do you set up the y-axis like that? You go to the graph options and you go to edit graph options. Here you can actually set up your optimal y-axis, because keep in mind you do want your graph, these are lines of best fit. So you want to stretch it out as much as possible so you can see how how the line changes. All right. And this is what happens today. So as you can see, it's kind of have a quite dramatic climb up to here, up till about 3 minutes in. And then you see the the CO2 concentration kind of slowly, steadily goes up. We want to look for something like this in the data. Okay, so we do want to look for a portion where it's like a steady increase. Even, and as you see here, it's not perfect. Like you see some curve here and some valleys here. It's not perfect, but this looks good enough. So I just, to select this option, I just click, and basically I click and select. Okay. Now I already have a linear graph. And so after I have that, I will also click and to get the line up as fit, I say applied curve fit. And then just like typically you can, I don't want a second curve fit. Yeah, so in this case, you go to apply curve fit and then you choose which one it looks the best. Okay. Because my experiment is comparing CO2 concentration at different time interval as the seed was germinating. So in this case, it makes sense for me to use a linear line because I just want a one number, okay, for today, for 72 period. So I choose a linear curve, and I'm more interested in the slope, which for today it's 3.94. Okay, 3.94. So this 3.94 is the rate of change, how fast CO2 is used, or no, CO2 is generated per second. Okay, so that's the rate that I have. And what I did was I looked at my previous results. So as you can see here, I have my CO2 after 2 hours. So I can get the rate from here. After 24 hours, I can get the rate from here, 53 and 72. And what I did is I plugged it into Excel. Okay, I plugged it into Excel and I created a trend line. Okay, now there is certain part about this trend line I have not figured out how to do it so that it's a smooth line going up. There is this dip here which it does not necessarily make sense. Okay, so I think that is a limitation of using Excel to draw line of best fit, because this part I cannot get rid of this value. It makes more sense that it's slow curve straight like this, and then you have a line of best fit, a curve going up and down. Okay, so this is basically my, now of course I have to label my axes more clearly, so, along with the units. But that's basically what you do now after you have the data. You've collected the data. You select a portion of the graph that looks like it has a steady increase. Because of my experiment, I chose a linear line of best fit. I get the slope. And since my experiment, this trial experiment, is to see how much the rate of CO2 produced after after the amount of time for germination. So I plot these numbers into Excel and create a trend line. Your experiment might be a little different. Okay, you might, instead of doing CO2 production at how many days or how much time after you start doing exposing it to water, you might be doing some other things. I'm using CO2 produce, and as you see from my first video, you can also use O2 being used up, because keep in mind, it is an experiment measuring rate of cellular respiration. So for the equipment I have, you can either measure how much CO2 is being made, because that's a product of cellular respiration, or O2 being used. Okay, O2 being used. So hopefully, I hope this video helps. Let me know if you have any other questions. And hopefully I'll see you soon. Bye now.